In late 2022, the James Webb Space Telescope locked its mirrors onto Saturn's largest moon, and the image that arrived in Baltimore made a room full of scientists go quiet. NASA called it stunning. The people who actually read the data did not use that word. Because what Webb caught wasn't a portrait, it was a discrepancy. Bright clouds sitting in the wrong latitude for that season, haze layers thicker and higher than any Cassini-era model predicted, a methane signal running warmer and faster than every planning document assumed, and a first-ever detection of a molecular fragment that had no business being that easy to see. Wherever you're watching from tonight, ask yourself something honest. How much of what you think you know about Titan came from actual data, and how much came from the beautiful stills NASA chose to release? Because the two are not the same thing. And in this video, I'm going to walk you through what Webb actually recorded, what it implies, and why the scientists who understand it best have gone quieter in public than they were 3 years ago. Here is the thesis stated up front. Webb didn't just photograph Titan, it caught the moon behaving in ways the models did not predict, and the anomalies are not decorative. They are structural. They touch the chemistry, the climate, and every mission plan currently on the books, including one mission worth $3.35 billion that is already in fabrication and cannot be redesigned. Three signals stacked up fast. Mid-latitude tropospheric clouds appeared over Kraken Mare in November 2022, drifting where the seasonal models said clouds should not be. The stratospheric haze read brighter and higher than the Cassini baseline. And Webb detected the methyl radical, CH3, for the first time, a fingerprint of active photochemistry running at rates the standard models did not anticipate. Any one of those alone is interesting. All three on the same target in one campaign is a pattern, and patterns like that don't stay academic. They rewrite the atmospheric models. The atmospheric models feed the mission designs, and every mission design, including Dragonfly, the nuclear-powered rotorcraft NASA is building right now, was sized against a Titan that Webb is quietly editing in real time. What Webb saw is not the problem. What Webb saw implies is the problem. For 20 years, the public image of Titan was built by one mission and one probe. Cassini arrived at Saturn in 2004. The Huygens lander descended through Titan's atmosphere in January 2005 and transmitted from the surface for roughly 2 hours before its batteries died. Cassini itself kept flying past Titan until 2017, when it was plunged into Saturn to protect the moon from contamination. 13 years of data, hundreds of close passes, one landing that lasted less than a feature film. That is the entire foundation of what you think you know about Titan. It is a magnificent foundation. It is not a complete one. The narrative that emerged, methane lakes, methane rain, possible prebiotic chemistry, a place where life could plausibly begin, was not wrong. It was partial. Cassini saw fractions of one hemisphere clearly, across roughly 1/3 of a Titan year, at wavelengths its instruments were designed for. Its cameras had to punch through the permanent orange haze. Its radar mapped only the strips it flew over. The rest was extrapolation. Careful, professional, publishable extrapolation, but extrapolation all the same. And Cassini itself flagged the anomalies. Late in the mission, radar caught features in Ligeia Mare that scientists called magic islands, bright patches that appeared, disappeared, and reappeared in different configurations. Nobody has fully explained them. Waves? Bubbles of nitrogen coming out of solution? Floating solids? Every candidate is plausible. None is confirmed. The seasonal cloud observations drifted from what the models predicted. The upper atmosphere reacted to solar activity in ways the theorists were still arguing about when the mission ended. Let that sit for a second. The mission that gave us the Titan of the public imagination also gave us the first evidence that our understanding was thinner than the beautiful images suggested. Those cracks were already there. They just didn't make the press releases. Then Cassini burned up. For 5 years, Titan was studied almost entirely by ground-based telescopes and archived data. The models froze. Dragonfly's design work moved forward on that frozen picture. Then Webb turned towards Saturn. Different instrument, different vantage, different questions answerable. And the story it's telling is not the sequel anyone wrote. It is closer to a correction. Quiet, technical, devastating in its own slow way. Titan's atmosphere is about 95% nitrogen, about 5% methane, with traces of hydrocarbons produced by sunlight breaking those simpler molecules apart. Surface pressure sits at roughly 1.45 times Earth's, meaning if you stood on Titan without a suit, the air pressure would feel like standing 4 meters underwater. Surface temperature averages 94 Kelvin, minus 179 Celsius, minus 290 Fahrenheit. Now translate that. Titan is the only other world where liquid falls from the sky, pools on the ground, and evaporates back into clouds. There is a hydrological cycle, it just isn't made of water. It's made of methane and ethane, the same molecules we burn in rockets and stoves. Rain, rivers, and seas made of rocket fuel under an orange sky in a cold that would kill you in minutes. Standing on the surface, you would not need a pressure suit to keep from exploding, the way you would in vacuum. You'd need one to keep from freezing solid, while breathing what is essentially natural gas weather. You would suffocate slowly in weather no engineer has ever fully designed against. That is the baseline. That is the friendly, well-understood version. Webb's contribution was to look at that baseline with instruments, NIRCam, NIRSpec, and later MIRI, that could measure specific molecules and temperature profiles Cassini could not. What Webb found in November 2022 and again in July 2023 was, in polite scientific language, consistent with active tropospheric weather. In plainer language, the sky was doing things the models had not scheduled for. Here is the part that should bother you. Methane in Titan's atmosphere is not stable. Even the weak sunlight Titan receives, about 1% of Earth's, breaks methane molecules apart. On timescales of roughly 30 million years, that process should have destroyed all of Titan's atmospheric methane. There should be none left. But there is, roughly 5% of the atmosphere, steadily. Which means something is replenishing it, and nobody has confirmed what. The candidates, cryovolcanism, slow outgassing, a subsurface methane ocean, are all uncomfortable. Each implies Titan is more geologically active than we've directly observed. Each implies the surface we see is a thin skin over processes we do not yet understand. Webb's data narrowed the range and pushed the plausible answers toward the more active end. The mystery got deeper. It did not get solved. The methyl radical detection in 2023 was a scientific first. NASA described it as an important step. That description is technically accurate and profoundly incomplete. CH3 is a fragment. It's what you get when sunlight breaks a methane molecule and knocks a hydrogen atom loose. It is extremely short-lived, chemically hungry, and almost never observed directly. It exists only for the split second between being created and reacting with something else. Detecting it in Titan's atmosphere means Webb caught the photochemistry in progress, not the products, the active reaction itself. The polite reading is, This confirms the photochemical chain is running as expected. The harder reading is, the intermediate showed up at abundances and altitudes the standard models did not cleanly predict, which means the whole chemical machine is running at rates that force those models to be revised. That may sound like a technical detail. It is not. Titan's haze is produced by that photochemistry. Sunlight breaks methane, fragments recombine, molecules condense into aerosol particles. Those particles form the layers Webb imaged. If the chemistry runs faster than the models say, then the haze thickens, the surface gets harder to see from orbit, and every optical instrument in the mission plan degrades in performance faster than the planners priced in. Here is where this stops being academic. Dragonfly's instrument suite includes cameras. Its navigation depends on cameras. Its ability to select landing sites depends on being able to see through the atmosphere. Every one of those capabilities was budgeted against a haze density derived from Cassini-era models. If Webb implies the haze is thicker than assumed, the entire optical performance envelope has to be revisited before the design freeze. A design freeze happening right now, before the 2028 launch. Not in a decade. Now. Cassini's models were revised repeatedly during and after its mission. Every revision made Titan more complicated. Webb is continuing the pattern. When a target consistently produces surprises across successive instrument generations, the correct scientific inference is not, "We are almost there." It is that the phenomenon is more complex than the models can capture. And when the phenomenon is the atmospheric chemistry of a moon we are about to fly an aircraft through, that complexity is not just a paper. It is a risk. There is a mental shortcut almost everyone uses when thinking about Titan. Earth with different chemistry. Cold Earth. Weird Earth. The shortcut breaks the physics. Titan's year is 29.5 Earth years long. One season lasts roughly 7.5 Earth years. A summer on Titan is not a warm few months. It is nearly a decade of one slowly shifting configuration of sunlight. Gravity is about 14% of Earth's, roughly 1/7. Sunlight at the surface is about 1% of what Earth receives. Even at Titan's noon, you would be standing in what your eyes register as deep twilight. You could not read a book by the ambient light without help. Now combine those numbers. Air pressure 45% higher than Earth's. Gravity 1/7. Sunlight at 1%. That combination is not a variant of Earth weather. It is a categorically different regime. A methane raindrop on Titan is larger than any water raindrop on Earth, roughly the size of a small grape. It falls slower at a gentle drift. It hits softer, beautiful in the specifications. It is also a rain cycle that operates on decade-long clocks under a sun that barely qualifies as daylight. In that atmosphere, Earth-scale winds do work Earth-scale winds never could. Because the air is denser, a modest breeze carries far more momentum than the same speed on Earth. Wind shapes massive dune fields. Cassini imaged them across a substantial fraction of Titan's equatorial regions, under rules no Earth engineer has ever designed against. The dunes are hundreds of kilometers long. They are made of hydrocarbon grains that behave nothing like Earth sand. And the winds that built them are winds nobody has ever flown a machine through. The scale-like Earth intuition kills missions. Mars Climate Orbiter 1999 disintegrated because one team used metric and another used imperial. That was not a Mars problem. It was a scaling assumption problem. Titan invites the same class of error at a solar system distance with less margin to recover. The point is not that Titan is Earth-like. The point is that people keep saying it is, then designing against that assumption, then being surprised. Similar chemistry, different rules. Now bring a spacecraft into that. Now bring a rotorcraft. Now bring a human. Titan is often called the most habitable moon in the outer solar system. Read that sentence again. Most habitable is not habitable. It is a comparative against places like Europa's ice, Enceladus's frozen shell, and Io's radiation bath. Being the least hostile member of that group is not a compliment. It is a technicality. -179 Celsius is not merely very cold. It is a cold at which materials stop behaving the way engineers assume. Steel becomes glass brittle, standard lithium batteries stall, rubber seals lose elasticity, lubricants stiffen into wax. Everything you would rely on to keep a spacecraft or a human alive has to be re-engineered against a thermal environment trying, physically, to freeze the mission solid. Any breach is not an emergency. It is a sentence. It gives minutes, not hours. The atmosphere is not toxic like Venus, but it is not breathable. A human standing on Titan without a suit would not depressurize. They would suffocate slowly, in air, while freezing. A specific kind of death engineering has to design against, not the fast catastrophe of vacuum, but a slower one that gives no warning and no easy reversal. Then the isolation. Titan is between 1.2 and 1.5 billion kilometers from Earth. Radio signals travel at the speed of light. From Titan to Earth, that is between 68 and 84 minutes one way. A round-trip conversation takes nearly 3 hours. Think about what that means. A distress call reaches home in the time it takes to watch a feature film. Any decision that has to be made in less than 3 hours must be made alone. Any repair performed alone. Any medical emergency handled alone. If someone dies, we learn about it after they are gone. Apollo astronauts were 1.3 light seconds from Houston. ISS crew today are milliseconds out. A Titan crew would be 84 minutes out. That is not a longer version of Apollo. It is a different category of exposure. It is isolation with a mission patch. And this is the moon we're sending a nuclear-powered rotorcraft to next. Dragonfly is real, not a concept study. It is a funded NASA mission in fabrication with a launch scheduled for July 2028, arrival at Titan planned for 2034, and a projected cost of roughly $3.35 billion. That figure grew from earlier estimates near $1 billion. The mission is being built at the Applied Physics Laboratory at Johns Hopkins. It is an octocopter. 8 rotors powered by a multi-mission radioisotope thermoelectric generator, an MMRTG, the same nuclear power source used on Curiosity and Perseverance. Titan does not receive enough sunlight for a solar aircraft. The MMRTG is not a choice, it is a necessity. Dragonfly will fly. That is the headline capability, and it is remarkable. Short flights of several kilometers, hopping between sites, characterizing surface chemistry at the Selk impact crater, where past liquid water may have interacted with organic material. It is one of the most ambitious mission profiles NASA has ever attempted. Every hour of that flight plan was optimized against Cassini-era atmospheric models, wind fields, temperature profiles, haze density, all derived from Cassini and post-Cassini modeling. Webb's revisions, thicker haze, more active chemistry, tropospheric weather where it wasn't predicted, land during the mission's final build phase, when major design changes are essentially impossible. Now consider what Dragonfly is not. It is not Ingenuity. Ingenuity flew in Mars's thin atmosphere, less than 1% of Earth's density, with near real-time monitoring. Dragonfly flies in Titan's thick atmosphere, under 14% gravity, in perpetual twilight, on an 84-minute one-way communication delay, in weather models we now suspect are outdated. Every flight is autonomous, not because engineers prefer it, but because a joystick from Earth is physically impossible at that distance. Titan missions are rare. Titan missions take between 6 and 7 years just to travel there. Any failure at the destination is not correctable inside a career. There will not be a Dragonfly 2 in the 2040s. If this one loses a rotor at the wrong altitude, the entire program of Titan's surface exploration ends for a generation. The public framing describes it as a groundbreaking mission. True, incomplete. What it does not emphasize is that this mission's assumptions are being edited by Webb, in real time, during a phase when those assumptions can no longer be structurally revised. This is the mission being underplayed as safe. Read a NASA press release about Webb's Titan observations. Then, read the underlying paper. Then compare them. The press release uses words like unprecedented view, stunning imagery, confirms atmospheric activity. All true, all carefully engineered. Every word in a NASA public release passes through communications, science, and program review before it reaches the public. Nothing in those releases is accidental. The paper describes methane cloud detection at specific latitudes and altitudes. It notes departures from expected seasonal behavior. It discusses the methyl radical detection and its implications for photochemical modeling. It lists the ways the observations agree with prior models and the ways they do not, usually in more technical language, buried in the results section. Both documents are honest. Neither is complete. The press release is written for a congressional budget cycle. The paper is written for peer reviewers who already understand the caveats. The gap between them is not a lie. It is institutional caution. Agencies survive on stable narratives. NASA is defending Dragonfly's budget through a period of federal budget pressure and competing flagship priorities. Any public statement emphasizing Webb data is revising our Titan atmospheric models in ways that could affect Dragonfly's design assumptions would land in a congressional hearing within a week. So the release says unprecedented view. It does not say our models were wrong in the following specific ways. This is not conspiracy. It is not corruption. It is the ordinary friction between science, which is slow and iterative, and politics, which needs clear stories to keep funding flowing. Every large scientific institution navigates this friction. NASA generally does it well by international standards. But doing it well is not the same as doing it transparently. But institutional caution and public understanding are not the same thing. The Cassini precedent matters here. Cassini's most consequential findings, the disappearing magic islands, the unexplained methane persistence, reached the public months to years after they reached the science teams. Not because of malice, because working out what they meant took time. Webb is now in the early phase of that same cycle. The observations are in hand. The papers are being written. The public communications, meanwhile, emphasize the beautiful images. The stranger implications move through the pipeline more slowly, in language most people never read. Softer verbs where harder verbs would fit. Consistent with, instead of requires revision to. Defensible in isolation. Cumulatively, a distortion. Every world we have visited with a new instrument has surprised us. Europa was thought to have a relatively thin ice shell. Better data suggested it is thicker and more geologically active. Enceladus was expected to be quiet. Cassini caught it venting massive plumes of water vapor from a subsurface ocean nobody firmly predicted. Pluto was assumed to be an old, cratered, dead world. New Horizons in 2015 found young surfaces and possible ongoing geology on a body that should have been frozen still for billions of years. Io was known to be volcanic. Every mission revised the estimate upward. Every one of these was well understood until we looked closer. Every one. Not most. Every one. Titan is not an exception to the pattern. Titan is the pattern. The confidence we express in habitability rankings, in mission designs, in exoplanet analogies, is built on models that fail every time a better instrument arrives. That is not a criticism of the modelers. It is a description of the outer solar system. more active, more heterogeneous, and more surprising than the models keep predicting. Now widen that. Every Earth-like world in a JWST atmospheric spectrum, every exoplanet whose atmosphere Webb is now sampling, is being interpreted by the same class of models Titan just embarrassed. If we cannot cleanly model a moon we have visited, orbited for 13 years, landed on, and now observed with Webb, then our confidence in interpreting a planet we have only seen as a fraction of a pixel is doing a great deal of unearned work. The corrections tend to run in one direction. Bodies turn out to be more active than predicted, atmospheres more chemically complex, interiors more dynamic. That directional bias is a signal. It suggests our models systematically underestimate the activity of these worlds, probably because they were calibrated on Earth and the Moon and generalized outward with assumptions that don't hold in different environments. We keep announcing understanding, and the universe keeps issuing corrections. Which means the real question Webb raised at Titan is not about Titan at all. It is about how much of our supposed understanding of everywhere we have not been rests on models that keep being wrong in the same direction. Let me consolidate what Webb's Titan observations actually mean. The chemistry is running faster than the models predicted. The atmosphere is more active than the seasonal forecast suggested. The methane source remains unexplained. The haze is optically thicker than the baseline. Dragonfly's design freeze is racing incoming data revisions. The institutional messaging is systematically softer than the underlying science. And the pattern of surprises at every outer body we have visited is not slowing down. Any one of those in isolation is a normal scientific development. All of them arriving together on the same target is a warning, not fabricated, not conspiracy. A real, measured warning, embedded in the papers, softened in the press releases, and largely invisible in the public perception of a moon most people believe we already understand. The Webb image that opened this video is still beautiful. It is also, read carefully, an indictment of how confident we were the day before it arrived. That is exactly how science is supposed to work. Better instrument, better data, revised model, sharper humility. What is not supposed to happen is the public arriving at the revised humility 3 years later than the specialists. Let me be specific about what I am not saying. I am not saying Dragonfly should be cancelled. It should not. It is one of the most scientifically valuable missions NASA has ever funded. I am not saying Webb was wrong to look. I am not saying the scientists are dishonest or the engineers incompetent. They are, uniformly, doing extraordinary work under real constraints. What I am saying is that the physical reality of Titan is harsher, stranger, and less finished than the comfortable public framing allows. And that gap is not being closed by press releases. It is being closed, slowly, by papers most people will not read. The narrow hope is this. The instruments are finally catching up to the questions. Webb is doing what no previous observation could. Dragonfly, when it flies, will produce ground truth data nothing else can. Europa Clipper is on its way. Enceladus mission concepts are advancing. The outer solar system is being investigated more seriously right now than at any point in human history. Catching up is worth something. It is worth a lot. But catching up is not the same as knowing. When Dragonfly reaches Titan in 2034, it will not find the moon we described in the press releases of the last few years. It will find the moon Webb has been quietly showing us. One methyl radical, one anomalous cloud, one thicker haze layer at a time. Whether the mission survives the encounter with that moon depends on how honestly we listen to what Webb is saying right now. in the years when the design can still be understood against the newer data, even if it can no longer be fully changed. Webb saw Titan for the first time. What it really saw was how much we had been guessing. And that is the sentence NASA will never put on a poster.